Consider the motion of a simple pendulum. This is oscillating. In ideal situation, we assume that there is no damping and the motion will go on. Okay, but this does not happen. All of you know that the motion stops after some time. That is because of damping. Okay, because during motion the bob has to overcome air resistance. Okay, so in order to overcome that resistive force, its energy gradually decreases. Okay, and ultimately it stops. Okay, so if we consider the actual motion, then amplitude of oscillation is a function of time. Actually, if you consider the actual motion, then amplitude of oscillation is a function of time. Initially at t equals 0 is maximum, thereafter it gradually decreases. We find this amplitude as a function of time. Okay, considering the resistive forces. Consider the bob in this position. It is going towards the end position. It is moving towards the end position. So this is the direction of its velocity. In this direction, restoring force acts. All of you know that restoring force acts towards the mean position. Okay. In addition to this force, we will have to consider the damping force, which is mostly air resistance. Okay. What will be the direction of damping force? The direction of damping force opposite to velocity. Opposite to velocity. One example, you know one example, viscous force. What is the direction of viscous force? A body is dropped in a liquid. A body is dropped in a liquid, it passes through the liquid, its velocity is in this direction, then viscous force, all of you know viscous force acts in opposite direction. Okay, the viscous force is actually a damping force. Okay, so direction of damping force is always opposite to velocity. And then what about the magnitude of viscous force? 6 pi eta r B. So viscous force is, because this part being constant, viscous force is directly proportional to velocity. Okay, so viscous force is a damping force. See its direction. Its direction is opposite to the direction of velocity. Its magnitude is directly proportional to velocity. Okay, so in this case, we will consider this is the force exerted due to damping, Fd, and its direction, what is its direction? Opposite to velocity. And its magnitude, Fd, equal to some constant into V. Okay, so Fr, you know Fr equal to some constant into x. All of you know Fr equal to kx, and Fd equal to B into V, where V is a constant. K is called force constant, B is another constant. So Fd equal to B into V. So what are the forces acting against its motion? One is Fr and Bd. Total force acting against its motion is Fr plus Bd. Okay, now we will write the equation. M into A equal to minus kx. We are taking this direction as plus. We are taking away from mean position as plus. So Fr, since it is in this direction, minus kx, and Bv, since it is in this direction, minus Bv. Okay, hence Ma plus kx plus BV equal to 0. Okay, have we understood this? We are taking this direction as positive, FR in opposite direction taken minus, FD in opposite direction taken minus. Okay, so MA plus KX plus BV equal to 0, or M into dB by dt plus B into V plus K into X equal to 0. Okay, or M into d2 V equal to dx by dt. That means dB by dt is d2x by dt square. So d2x by dt square plus B into dx by dt plus K into x equal to 0. Okay, have all of you understood this? This is a differential equation. This is a differential equation. So it has a solution. That solution is x equal to solving. The solution is not included in your syllabus. Only you will write solving the expression of x. Solving x equal to a naught into e to the power minus bt by 2m, a naught into e to the power minus bt by 2m cos omega dash t plus phi. So this is an important equation. This is a differential equation. Its solution is not included in syllabus. Only the solution, you have to memorize this because the process has not been shown. So x equal to a naught into e to the power minus bt by 2m cos omega dash t plus phi. This is the amplitude part. This is the amplitude part. So you can see from this expression that amplitude of oscillation, it depends on time. Okay, and the function is such, as time increases, amplitude of oscillation will decrease. This is the amplitude of oscillation. Okay, a naught into e to the power minus bt by 2m. That means amplitude of oscillation is a function of time. As time increases, amplitude of oscillation will decrease. Okay, so A equal to you will remember this expression because in JEE Main 2 times problems have come from this expression. 2 times in 2 years. So A equal to a naught into e to the power minus bt by 2m and omega dash equal to, remember the result, omega dash equal to root over k by m square minus k by m square minus, I also do not remember it exactly, k by m square minus now root over k by m minus b square by 4m square omega dash equal to root over k by m minus b square by 4m square and energy of SHM, energy of oscillating body. What is the basic formula for energy of oscillating body? All of you know that it is half m omega square a square. Half m omega square a square. So it will just be written as half m omega dash square into a square. A square equal to a naught into e to the power minus bt by 2m whole square. A naught is the amplitude of vibration at t equal to 0. A naught is the maximum amplitude of vibration. When is the amplitude of vibration maximum? At t equal to 0. When you have released the body, it will vibrate with maximum amplitude, then the amplitude is gradually coming down. So A naught is the amplitude, A naught is the amplitude of vibration at t equal to 0. Write this, A naught equal to amplitude of vibration, amplitude of oscillation at t equal to 0. Amplitude of oscillation at t equal to 0. Damped vibration. Once again I am explaining. Ideally we do not consider any damping force. When a pendulum bob is released, we assume that it will go on oscillating, but practically it does not go on oscillating. It stops after some time. Okay, that means there is damping of the motion, and the cause of this damping is obviously air resistance and friction. So due to air resistance and friction, the energy of the body gradually decreases and the body ultimately comes to a halt. It stops. Okay, so amplitude of oscillation is actually a function of time. At t equal to 0, the amplitude of oscillation is maximum, and then amplitude of oscillation gradually decreases. We will have to find amplitude as a function of time. Okay, for that we have considered the damping force. Two forces are, this is the bob. It is going in this direction. Its velocity v is in this direction. Two forces are acting on this. Restoring force acts on the bob. You know that it is directed towards the center. That is already known, and we have already, in our previous discussion, we have taken care of this. We know effort. In this, we are considering another force, which is the force exerted due to damping. This is mostly air resistance. Okay, what is the direction of force due to damping? Direction of force due to damping is opposite to the direction of velocity. I have given an example. Viscous force is also viscous force has similar nature, damping type. The velocity is downward, viscous force is upward. Okay, so viscous force is opposite to velocity. This force is also opposite to velocity. Then viscous force equal to 6 pi eta r into V. Viscous force is directly proportional to V. So this damping force is also directly proportional to V, where B is a constant. So damping force equal to B into V, just like viscous force equal to some constant into V, and restoring force equal to K into X. So these two forces are acting on the body towards the center. Okay. Now I have written this equation, which is most important equation. This is most important equation. I have taken this direction as positive. X, what is the direction of restoring force? Direction of restoring force is towards the center. That's why this is taken as negative. Direction of damping force is also towards the center. That's why it has been taken as negative. Okay. So MA is the net force. MA plus Kx plus BV equal to 0. Okay. Resultant force equal to Fr plus Ft. Both are negative. Okay. So you have got this equation. This is also an important equation. This is also an important equation. This is a differential equation. How do you get this? Writing V equal to dx by dt. So V into dx by dt. and then v equal to dx by dt. dv by dt is d2x. You know d by dx, dx by dt is what? This is written as d2x by dt square. Okay, so then this differential equation is solved. Solution is not included in your syllabus, only you learn the result. Solving x is how much? A naught into e to the power minus bt by 2m cos omega dash t plus phi. Okay, a naught is the initial amplitude, means amplitude of oscillation at t equal to 0. This is the amplitude part. Okay, you can see amplitude is a function of time. As time increases, amplitude decreases. Okay, and this omega dash it has this expression root over k by m minus b square by 4m square. Okay, so you will memorize these two. This is important. Box this, and energy of SHM. What is the energy of this? Half m omega dash square into a naught e to the power minus bt by 2m whole square. Okay, write a problem. So with time amplitude will decrease. Amplitude will decrease with time. Right. Damping force acting on an oscillating body equals to 0.5 V, 0.5 V. Mass of the body is 10 gram. Mass of the body is 10 gram. In what time will the amplitude of oscillation be reduced to 50% of the starting amplitude? In what time will the amplitude of oscillation be reduced to 50% of the starting amplitude? All of you can solve because you know amplitude as a function of time. So there is no problem. After time t, amplitude will be reduced to 50% of the starting amplitude. So starting amplitude, all of you know that starting amplitude is A naught. So put A equal to A naught by 2. A naught will cancel and you will get the time t. So amplitude A equal to A naught e to the power minus bt by 2m. Most important expression in damped oscillation. Or A equal to, according to the problem, 50% of the maximum amplitude or starting amplitude. A naught by 2, A naught into e to the power minus b. B equal to 0.5, na? 0.5 t, 2 into mass. Mass is 10 gram, so convert it into kg, 0.01. Or A naught cancel, half equal to e to the power minus t by 4 into 100. means 425. 425, so minus 25t. Now take log on both sides. Log half equal to minus 25t. Okay? Or log half equal to minus log 2 equal to minus 25t. Or t equal to log 2 ln 2 by 25.